I want to talk a little bit more about factoring sum and difference of cubes, which we talked very briefly about in the last video, but is usually pretty challenging for kids to try to figure out. And so I'm going to work some examples here, but then I'm also going to extend it beyond just cubes, and we're going to see there's a kind of a greater pattern going on here that are sum and difference of odd powers. And I don't know if it helps you, but for me, it helps me remember how to factor the sum and difference of cubes when I see how sum and difference of cubes are really part of something bigger. So I've written here in blue the formula, if you will, or the pattern, or the way that we factor the sum of two cubes. And then I also have in green the factorization for the difference of two cubes, and we have a subtraction sign. And so I'll do an example here first of one of each of these. Let's do the x cubed plus 27 first. So we're thinking of this, and you can write this out if it helps you keep it straight. You don't need to do this step if you can see how to get there without it. But you can see that the 27 is a perfect cube. It's 3 to the third. So in our pattern for the factorization of the sum of two cubes, we're going to use x as our a and 3 as our b. And so our factorization will become x plus 3. That's the a plus b. And then the a squared will be an x squared. The minus sign comes from the pattern. And then a times b is going to be x times 3, which I'll write as 3x. And the b squared is going to be 3 squared, which is going to be 9. And so that is going to be our factorization for x cubed plus 27. So let's do one with the difference of two cubes, and I'm going to step it up a little bit. Let's suppose we have 8x to the third minus 125. Now the first challenge is to recognize that 8 and 125 are perfect cubes. So 8 is 2 to the third, and 125 is 5 to the third. So if it helps to think of it that way, I wouldn't probably write this out, but when you're starting out, this might be helpful. We can think of 8x to the third is coming from 2x times 2x times 2x, and the 125 as being 5 to the third. So in our pattern for factorization of difference of cubes, we're going to get first the binomial term is going to be the a minus b, which for us is going to be 2x minus 5. And then in the trinomial term, we're going to get the a squared is going to be our quantity 2x squared, and 2x times 2x is going to make that be a 4x squared. The plus AB is going to be our A2x times the B5, and so that's going to make that middle term be a 10x. And then we're going to get plus the second one squared, which is going to be then a 25. So that's a couple of examples. I want to show you this as part of something even bigger. So if we can build on this sum of two cubes and look at the sum of any odd powers. So suppose we went bigger than cubes and we had something like a to the fifth plus b to the fifth. Here's where I think you can kind of establish what the pattern really is and what's going on there. So it also is going to start with a binomial term, and so it will look very much like our factorization of the sum of two cubes. We'll start out with an a plus b. Then the pattern that I tried to mention in the last video, but it didn't really have anything to connect to, is what's going to follow here is I'm going to start with a to the 1 less than 5. So it's going to be a to the fourth, and I'm going to have b to the 0 on the first term. Just as we had here, a to the 1 less than 3 would make that an a squared and no b term at all. Now the pattern that's going to follow in this when we have the sum of two cubes is they are going to alternate signs. So I'm going to go minus, and then I'm going to go, the next term is going to be down one more in a, so I'm going to go down in powers of a. That's going to become an a to the third, but I'm going to go up in powers of b. So I had b to the 0 on the first term, so that's going to make this be b to the first. And now the pattern will continue until I run out of a's. So I'm going to alternate signs. So this is going to now be a plus on the next term. I'm going to go down in powers of a. That's going to make that now be an a to the second. I'm going to go up in powers of b, and so that's going to now make that a b to the second. The pattern continues. So now I'm going to alternate sign and get a minus. Down in powers of a will take us to a to the first. Up in powers of b will make us be b now to the third. And then finally, alternating signs will get a plus. And now I'm going to go out of a's, so no more a's. I have no a's at all. Up in powers of b, I'm going to make this be a b to the fourth. So you can kind of see that if we multiply this all out, we're going to get some telescoping. The only terms that are going to survive is the first one, which is going to be our a to the fifth, and the very last one, which will turn out to be a plus b to the fifth. So here again, the patterns are for the sum of two odd powers. The binomial term matches the original. Then you go down in powers of a, up in powers of b, and you will alternate signs. There's other patterns you can notice. If you look at the exponents, I'm trying to get a different color here. So if you look at the sum of the exponents at each of these terms, they're always going to add up to be 4, which is one less than what we started with there. So there's lots of other patterns going on there. Now let's see how this compares and contrasts with the sum of odd powers. So let's do, say, I'm going to go even bigger, a to the seventh minus b to the seventh. So again, this works with odd powers only. Now here, like we saw with the green a cubed minus b cubed, the binomial term is going to still be an a minus b. It's going to match the signs of the original. Now I'm going to use the same idea that we did in the a to the fifth plus b to the fifth. I'm going to go down in powers of a, up in powers of b, but in the case of the difference of two odd powers, all of these terms are going to be positive, as you saw was in the green factorization of a cubed minus b cubed. So going down one power of a takes us to a to the sixth, so that when that a multiplies the a to the sixth, we'll get the a to the seventh. All the signs are going to be positive here. I'm going to go down in powers of a and up in powers of b. So that's going to make that be an a to the fifth, b to the first. And then I'm going to go down in powers of a, up in powers of b. And I'm going to continue down in powers of a, up in powers of b, until I get a final term that has no a's in it at all. So we're going to go, here's a to the first and b to the fifth. And then finally the a's are gone and we get only a b to the sixth, so that our last b times b to the sixth will get us that b to the seventh. So these get pretty long and crazy in a hurry, but let's just see one example of how this might work. So let's do something we can actually sort of handle, maybe. Let's say we're going to go, I'm going to take 3 to the fifth. 3 to the fourth is 81, times 3 is 243 x to the fifth. And I'm going to go plus 2 to the fifth is 32, so I'm going to call that 32. So, and I'm going to leave myself some space here. So we're thinking of this as 3x quantity to the fifth plus 2 to the fifth. So those are our odd powers of 5. So we're going to follow the same pattern that we see for the sum of two cubes. But the role of A is going to be played by 3x, and the role of B is going to be played by 2. So we will start with a 3x plus 2. That's our A plus B. Then we're going to go A to the fourth. So 3 to the fourth is 81. So that's going to be 81 x to the fourth, and we have no b's, no 2's. We're going to alternate signs, so that's going to be a minus. Now I'm going to take the 3 to the third, which is 27, times, we're going to get a b, which is a 2, and so 27 times 2, I believe, is 54, x to the third. And then we're going to alternate signs. So now we're to 3 to the second, so that's going to be 9. We're up to 2 to the second, that's 4. 9 times 4 is going to be a 36, x to the second. We're going to alternate signs, so now we've got a minus. And we're going to get 3 to the first, so that's just 3. And we're going to have, do I have that right? 2 to the third, right, 2 to the third, which is 8, times the 3 is going to be a 24, and now we just have x. And finally, we got no more x's, no more 3x's at all, and we're up to 2 to the fourth, which is 16, and there is our crazy factorization. So hopefully this helps the sum and difference of cubes make a little bit more sense. I know the first time I saw this, that helped me. Just seeing the bigger picture, what happens with the sum and difference of higher odd powers, helped me remember the sum and difference of cubes.